Yo. So, what do we got going on here? I'm currently planting hay. My goal is to be planting maize, right? So, I actually let me run cacti real quick just because I want to show it off. Let me run cacti except instead of world size. Okay, where do I use world size? Travel. Yeah. Let's change this really quick. Instead of world size, let's do like 8, 8, 8, 8 minus 1. Sure, I just don't want to mess anything up. And then in cactus, anytime I say get world size, change that to 8. Just to show how this works. Get world size 8 and 8. Okay. Yo, what's up, Zach? Okay, so now if we run. Wait, what? Okay. Run cacti. What it'll do is plant a square of cacti. What are you doing? Oh, because that's right. Okay. I need to return to. Oh, dang. That means none of this is going to work actually. So let me go ahead and undo everything. And current cactus is not equal to none. Okay, hopefully I didn't just break anything. And then let's put this back. Okay, what I need is treasure. So let's start with mazes. The way that mazes work is we plant a bush and then we use weird substance on it to make a big maze. This is weird substance. So run the run it. What's happening? Oh, okay. 'Cause I'm not calling it. I need to call maze. So let's bring this over here. What's up, bracket? So this makes a maze. Um, and somewhere in this maze is treasure somewhere. There. We need to get there. Now, it would be possible for me to just look at it and say, okay, north, east, east, north, north, east, 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 north, east, north, north, east, south, south, east, north, 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 east, west, 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 whatever, whatever. I could solve this maze manually and get this treasure. That would take a really long time. So I'd much rather just have it do it for me. Um, I do want to unlock something. Actually, it doesn't matter because right now what I'm going to do is I'm just going to, instead of this, I'm going to keep it actually. I'm going to keep maze size equals this because this just calculates how to get the largest maze that I can get. Yeah, and for now we're just going to do like 5. So if we run this again, it should make a maze with what's happening. We're using that and it's not giving me a maze. Plant a bush, use weird substance. The substance isn't being used. Oh, because I need a lot. Okay. How much does 10 give me? Okay, 100 gives me that. Let's do 1,000. Just try and get a good sized maze here. Okay, that's way too much. Let's do like 150. Okay, just a little more, like 200. Sure, okay. So now we have this maze. Pretty simple, actually. I could solve this very quickly. I just take me a couple minutes to write out. What I would rather do is have it solve it itself. I've done a little bit of research. I want to try a recursive algorithm. I'm not 100% sure how to do that. And actually, I don't like the way that I have my function set up right now. I'm going to go main. I'll actually use clear here because I'm planting a maze. Doesn't really matter. So clear and then this. And then, I guess, yeah, I'll take this too. Use item, and then I'll call maze, and that will solve the maze. And then this will just call main maze. Okay. This is how all my other ones are set up. So I'm gonna need to pull up. Wait, what is this error? Spawn a full size maze, truncated out. Oh yeah, I know. I'm using a weird number. Whatever. I don't care about that. So let me pull up this. So I'm not gonna copy exactly. I'm not just gonna like copy and paste, but I do have a method that I want to use, and then I have another method that I want to learn about. So for now, I do want this. Where's my buttons? Not made an array in a long time. North. I'm gonna do northeast, south, west. What's the button? There it is. Okay. And then, so for maze, it's going to um, we want a for loop that goes in each direction. So for direction in directions. So this is basically going to run through this however many times there are. So it's going to run through it 4 times, and each time direction is going to be equal to the next value. So it's going to, the first time it runs, direction is going to equal north, and then next time it runs, it'll equal east, and the next time it runs, it'll equal south, and the next time west, and then it'll be done. Um, Wait, how do I do that? Right. This is where it gets weird. Um, what is it? Sorry, I am looking at a thing. Not turn false. Okay. Before that, we can have this. If not move direction. Yeah, because we'll actually be intaking a direction here, I think, or we should be. Right? Main maze. Yeah. This main needs to have well, it's gonna be while true. Oh well, it's gonna include that. While true. Um this and maze is gonna be in for uh direction in directions as well. And then it's going to call maze with that direction. So we have maze being ran and then coming to here. And then if it doesn't move, if that doesn't work, then we return. And we actually want to return false. Actually, I forgot why. I'm not going to include that. I know that I need it, but I'm not going to include the return false yet because I don't remember why I need that. But why is my return? There we go. So if that doesn't work, returns false, or it just returns for now because I forgot why I need to return false. But then we'll have another one that is, if we're on the treasure, harvest and return true, right? That's right. That's why. Okay. Harvest and return true. If get entity type is equal to entities dot treasure. Okay, that should be good. Yeah. Returns true. So this will return false if not. Back to here. Now we're almost done because now we just inside of this for direction and directions we do if direction is not equal to opposite direction, which I don't isn't a thing yet. I'm gonna need to make another thing called opposite direction, and it's gonna return a direction. So if direction is equal to north, return south, and then well, yeah, you get the point. If it's south, it should return north, and then if it's west, it should return east, and if it's east, it should return west. North, south, south, north, west, east, east, west. So this is just returning the opposite direction of whichever direction was passed into maze. And as long as it's not that, we're going to run maze again with the direction, with this direction. And does that actually work? Yeah, I need to have this be a different direction then because this is going to be, I'm just going to call it next direction. And as long as the next direction is not equal to the opposite of the direction we just went previously, we're going to do the same thing going in the next direction. So this is a bit outside of my, like, I understand how it works. It just isn't intuitive yet. Oh yeah, I forgot to be having chat up. Oh, it doesn't matter because no one's here. So this isn't the most intuitively understood by me right now, but I do understand it. What happens, we call this, and it goes north first, right? So then it goes through here, move north. If that worked, then it continues. If it didn't work, then it stops and goes back and goes south. Oh, hey, I see. I didn't mean to be like pessimistic. I'm making sure I'm not missing anyone asking questions. So, yeah, the way this works, if north works, it does move north. Like in this situation, let me go where I can see both. It would move north, and then it would not be over the treasure, so it would continue, and then it would for next direction and directions, it would try to move north again, so long as north it knows that north is in the opposite direction. So then it would try to move north again, and we'd be back up top in a new iteration of this. Even though this is still going, we're in a new one. It's recursive is the term. And then it will try north, and then when north doesn't work, it'll try east, and then it'll try north, and then when north doesn't work, it'll try east, and then when east doesn't work, it'll try west, or sorry, south. And it won't do south that time because it knows that we just came from there. So then it'll try west, and that'll work, and then it'll go north. It's a big loop. This should work, I think. What? Oh, of course. Always got to miss something. Yeah. So then it breaks because we don't have it set up to go back to the starting position. I am going to include that though. Let me just from lib import all. It's my library. Oh, you're cool. You're cool. So now all I want to do, this works, this solves the maze. Then we're going to returns true, so it stops. For direction and directions. Is that all I need? I think so. But just afterwards, we need it to reset position, which is a thing that I made here to put me back to correct spot. I think we're good. Something tells me we're not good. Okay, what's happening here? Okay, it's not opposite directions, so we move. What is the direction this time? North. Okay, north doesn't work. East doesn't work. South works because I guess we came from here. South works. What is it now? South, right? We just did that. So now, north. Uh-oh. But it doesn't want to go north because north is the place we just came from. Now it's going to go east. Uh-huh. And there's nowhere to go. Oh. Because it does north, east, south, west. But it doesn't keep track of where it came from 2 steps ago. So wait. Did I... For reference, I didn't make this. I am referencing someone else's code to do this. Not exactly, but I think it's the exact solution. Same logic, at least, right? Um, wait. It's not exactly the same. The only thing that's different is this, though. This is all same. Move opposite direction. Yeah. Oh. Right. I forgot one step. So at the end, in here, we can't just explore and then be done. We're not done. We still need to if opposite direction is equal to direction. Okay. I see. So we did this a little bit differently. Explore path, explore direction. But that works the same. What we didn't do is move opposite of direction. And that's all we need. Should be. Let's try it. Okay. Not. Wait, what is that? Oh, because it's in. Sorry. Okay. There we go. And now we can put our this back to normal. So it does that, and then it resets position, and then it plants. Wait, that should work fine. Why doesn't it plant again? Does it get stuck here? Return true. If return true. Wait. Oh, okay. This needs to be expanded a little bit. If so, instead of making sure it's not equal, we need to continue. So we just go to the next direction, and if it's not equal, which means it's fine, then we still need to do if maze. Next direction. Then return true. Right, okay. Because it's dependent on itself. I need to return true so that once we hit the end, this returns true to the last one, to the last one, to the last one, to the original one where this can stop. Okay, that makes sense. Now we should be good. Nice. And it's still doing that. I think this is a problem with what I'm doing here. Don't know why. So this is just the first maze solution. The next one, the reason I wanted this is just to get the first one. The real challenge is getting 300 mazes in a row while it takes away walls. But I have a strategy that I have a article pulled up that I'm hoping will help me learn this. I don't have just a block of code that I'm basically copying from like I do with this one. Clear plant bush. Reset position. Yeah, why doesn't that work? Oh. Oh, because it doesn't get out of this. It doesn't get. Oh, right, because of course it doesn't get out of this. Literally the thing I just stated why this is needed. If this, then break. And then it breaks and well, actually, can I just because then it's not going to reset position. I guess we can just do clear. It doesn't matter. We'll just put the clear inside the true loop. Yeah, that doesn't matter because it's not. There's not going to be anything there. So this should work now. Nice. And then the only thing I want to change is instead of doing that, I'm just going to take this and put it here and delete it because I don't like storing variables that are only used once. It doesn't make sense. There we go. Now this should find the treasure eventually and give me a ton of treasure, a ton of gold. Where's the path? Here, here. Oh my gosh, is it like back towards the start? Oh wait, I think it's getting close. No. Yeah, it was like all the way back towards the start where it needs to be. So it's backtracking a lot. Oh goodness. Hey, if there's a problem in the code, this is where it'll be found. Nope, it found the right path. Or it's about to. Oh my gosh, it's going all the way over there. The correct place I needed to go was here, and then into here, and around here. And instead it went up. Oh gosh. Okay, it worked though. That was the hardest one, and we got 47,000 gold. So we can unlock set speed. Finally, the debug. We can set the world size and the execution speed with this. That's awesome. Is that it? Reduce execution speed, farm size, very useful. What's even more useful is simulation. File name, sim unlocks, sim items, sim globals, seed up. I don't know exactly how that works. File the execution should start in. Start with everything unlocked and fully upgraded. Yeah, okay. Start with 10,000 carrots and 50 hay. Sim unlocks equals unlock sim items. Okay. Items 10,000 hay 50. Global variable A with a value of 13. Okay. Random seed. Seed. Interesting. Speed up the simulation by a factor of 64. I don't think I'm going to mess with C. Oh, I guess checking for which strat is more consistent or faster would be good. But only marginally. Speed up simulation by a factor of 64. Cool. Run. Returns time in seconds that it took to simulate this given start file. Okay. Starting unlocks, starting globals. Random seed up. Speed up. Okay. How's this doing? Treasure's here. Solution is right at the start. So this is going to take an extremely long time. I'm kind of just chill watching it though. So satisfying. But yeah, it's going to go through like literally everything before it gets here just because of the starting direction. The fact that north is first. If north was last, then it would have gotten this like immediately. There we go. Okay. Now I need to learn a new way to solve a maze. And it includes knowing the the point at which we're trying to get to. The point that we're trying to get to is what I need to know. So what I'm going to do is stop this. I'm going to keep this here again. Size. I'm not typing. Size equals that. And then we're going to change this back to 250. And then instead of when we find the treasure, harvest, return true, we're just going to return true. And we're not going to harvest. We're going to okay, what do we have to do? Because we need to mazes for the extra challenge. Where is it? Where is it? Loops. Where is it? For an extra challenge. Okay. If we use the same amount of weird substance on the treasure again, this will increase the amount of gold in the treasure by one full maze and move it to a random position, and it will remove some of the maze's walls at random whenever you do that. So it'll be the exact same maze, except some walls are missing, and the treasure is more valuable. This could make it faster to get treasure, to get gold. Or it could just be a fun challenge. Either way, I'm going to do it. I think it is faster because one cool thing about it is that wait, is this, doesn't it let me see measure? Yes. Shows you how to approach a problem. If you have no idea how to get to the treasure, using measure anywhere in the maze returns the position of the treasure. Oh, wait. At any time? I thought that that was part of the extra challenge. Measure anywhere in the maze returns the position of the treasure? Wait, that's a cheat code. I don't even need this way that I just learned. Because I'm going to be using depth first search, which is an interesting algorithm. Also, this is the guy whose code I stole. I wasn't going to steal it exactly, but I ended up stealing it exactly because the slight changes I wanted to make didn't work. So good on this guy. This though is what I'm looking at right now. Depth first search. So let me make sure mazes are composed of walls. Yes. Okay, good. Maze has a starting point and an ending point. Yes. Okay. We only care about finding the first available path. This is what I like about this method instead of something like Dijkstra or A asterisk, because some of these other ones that I've been researching would work, but they would find me the fastest possible path to get to the treasure, which doesn't matter at all because it takes longer to find the fastest path. I just want to have the fastest way to get there one time, and then I'm good. So, we wait. Does depth first search work in a maze with loops? Um, is that a yes or a no? Is that a it can? It fails. Is there a way to make it work? Chat, this might not be the strat. Um, loop. You see, in this example, there are no loops. This is showing a maze, and I believe each of these would be like, wait, or is this? Maybe I'm reading into this. One way to represent a graph. Example, we're only concerned with the fact our graph contains the nodes and edges. Hold all the data that we care about. The numbers in the nodes represent IDs. The visited property defines a way that we can determine if we've seen a node already. That way we aren't traversing over nodes multiple times. Edges are what link nodes together. If there's no edge between two nodes, like in the instance of node 3 and 5, we can go back to our second assumption, mazes have walls, and use no edge as an indication that we can't travel in that direction, aka a wall is there. We can have an array of every point and assign a value to every point of whether it's been visited, and also a value of every point of which direction has a wall. Every time we visit a point, we could do that. Wait. But then, let me keep reading. Traversing, yes. Let's start running. Remember the first assumptions, graphs typically don't have a designated starting point, but in order to perform depth first search, we have to start somewhere. So we'll start with node 1. Okay. And actually, I don't need to keep. Oh, well, I would want to keep track of every point, not just points with intersections, because walls are being removed. Okay. Mark it as visited, so we don't. Okay. See if node 1 is equal to the node we're looking for. Okay, and in this, we do know where we're looking for, which is true for our case as well. We then check it to see if node 1 is equal to the node we're looking for. It isn't, so we move on to node 1's adjacency list. Every node holds a list of references to all nodes that they are connected to. We see that node 2 is connected to node 1 and move on to the next step. That's the only place we can go. Okay. After looking at node 1's adjacency list, we end up evaluating node 2. Yes, the steps are similar. We mark the node as visited and then check to see if it's equal to the node we're looking for. It's not, so we call DFS on node 2 to go even deeper. Okay, now we're going to go into one of these. We see that node 2 is connected to node 1, 0, 3, and 4. That's 4 edges, meaning 4 different paths we can take. How do we choose? In all honesty, the actual nodes we choose don't matter. The order is entirely dependent on how we stored our nodes in the adjacency list. Yes, this is just why sometimes I find the treasure immediately, and sometimes I have to search the whole maze for it first. The order is entirely. This is what we have right now, is it not? For completeness sake, I'll show, but we don't use that, do we? This is not the method I was wanting to learn. I think I've mixed up my methods, my maze solving methods. Now we move on to node 0. We go through the same routine as before. We mark it as visited, check if it's equal to node 6, and then call depth first search on node 0 to try and move deeper in the maze. We have noticed that the only connector node 0 has is to node 2, which we've already visited. Well, we hit a point where we can't go further down a path, so no more functions are added to the stack. Instead, we have to do something called backtracking. Yeah, okay. The call stacks words by evaluating function calls. It's sort of a nested structure. Node 1 and node 2 are still in the stack because they are still a part of the potential path. Once we hit node 0, no other path exists. That means we're done with the FS call on node 0, and hence we have to backtrack to node 2. Yes. Okay, and now we continue on the list. Okay, we do that. We go back, kick that out. We end the DFS call on node 3. Okay. Here's 8 and 9. We visit compare and call DFS on each node. Only once we hit node 6 does our goal check finally become true. Now, if you look at the cell stack in figure 9, you'll notice that it contains a path from node 6 all the way to node 1, all thanks to backtracking. Now that the function has finally evaluated to true, we can begin to remove all our DFS calls from the stack and print off the values, thus giving us our path. But I don't want a path, I just want to get there. I thought that was the thing. What about the maze thing? That's exactly how we'll solve our maze. I got it. Um, yeah, okay. That cool. Yes, very cool. Um, if there were a loop, it would loop forever. That's why I can't do this method for. This is what I have. This is this. Okay. I need something else. What is the one? uh, Different maze solving algorithms. I watched a video a long time ago where it showed different maze solving algorithms, and there was one that I thought it was depth first search. I didn't realize that's what I just did. I probably should have. Did it say it in here? He probably said it. I didn't watch this whole video. Oh, depth first search. He definitely did. I watched like the first third. I skipped this. I went here and here and had it muted most of the time. But what else is there? Dead end fillings. That's how to make a maze. I did watch this video. So that's just a shortcut from it. Wikipedia. Help me out. Random. No. Hand on wall. Tempting, but no. And it won't work with loops. Ledge. The wall follower method. Designed to circumvent obstacles. Arbitrarily chosen direction to go forward. One hand is kept along the obstacle. Um, okay. This is a maze with loops, which is good. And it's tracking. Ooh, I like this. It's tracking. Only intersections. And it's marking off every possibility on the map. It doesn't get the shortest path. That's not. I don't think this is any more efficient than what we have already. Oh, this is the same maze, same algorithm used on it with a different array. I guess just to note that it can take longer. Mm-hmm. That's cool. Dead end filling. Algorithm for solving mazes. Oh, this is for solving? I thought this was for making mazes. That fills all dead ends, leaving only the correct way. Oh yeah, this is a cool way. Oh, I remember. I don't want this. I don't want this. Recursive. Wait, is that what I'm doing right now? Recursive. X and Y. If the X and Y values are not a wall, the method will call itself adjacent X and Y values, making sure that it did not already use those X and Y values before. If the X and Y values are those of the end location, it will save all previous instances. Method. This is depth first search, isn't it? This is in Java. Maze routing. Low. Oh, wait, this is the one I wanted. Maze routing. I think this is the one. Low overhead method to find the way between any two locations of the maze. The algorithm is initially proposed for chip multiprocessors. Grid-based maze. In addition to finding paths between two locations, the algorithm can detect when there is no path between the source and destination. Also, the algorithm is to be used by an inside traveler with no prior knowledge of the maze, with fixed memory complexity regardless of the maze size, requiring 4 variables in total for finding the path and detecting the unreachable locations. Nevertheless, the algorithm is not to find the shortest path. That's fine. The only thing that seems like a limitation I don't need is that it doesn't store memory. If I have one that stores memory and can get the shorter path because it knows the maze already, that would be cool, but this might work. Maze routing algorithm uses the notion of Manhattan distance. Manhattan distance. Where did I watch someone do Manhattan distance? Was it this guy? No, it was this guy. Yeah, he made some cool videos on this game. I started watching this and then I was like, you know what? I just need to learn this on my own because it was a bit much. Lies on the property of grids that the MD increments slash decrements exactly by 1 when moving from one location to any 4 neighboring locations. Here's a pseudocode. Okay. Without the capability to detect unreachable locations. That's fine. I don't need that. Every location is reachable. Point, source distance, source and destination coordinates. Okay. Um, also indicates the coordinates of the current location. Okay. Integer MD best equals MD source distance. Okay. Stores the closest MD we ever had to distance. Destination. Sorry. Stores the closest MD Manhattan distance. Oh, yes. Yes. This is exactly what I was looking for. Um or maybe not exactly, but it's agent maze. Active expiration. Oh, wait. Multiple mobile agents to move at the same speed. Wait a minute. Communication between the agents. Oh, I don't know if I have communication between them. Because I can have multiple drones. Um Especially in the case of trees, the study depends on the model of communication between the agents. The centralized communication model, the agents are allowed to communicate at all times with one another. In the distributed communication model, the agents can communicate only by reading and writing on the walls. I can't read or write on the walls or communicate with, so I don't think that'll work. See also, I think maze algorithms. Maybe. What's this? Is solving mazes. Wall follower, pledge, chain. Smaller mazes, links into chain, solving them in sequence. Specify the start and desired end locations, and the algorithm will always find a path from start to end if one exists, where the solution tends to be a reasonably short, if not the shortest solution. That means this can't solve mazes where you don't know exactly where the end is. That's fine, I know exactly where the end is. This is most similar to pledge algorithm since it's also essentially a wall follower with a way to jump between islands. Interesting. Start by drawing a straight line. Doesn't double back on itself from start to end, letting it cross walls if needed. Then just follow the line from start to end. If you bump onto a wall, you can't go through it, so you have to go around. Send 2 wall following robots in both directions along the wall you hit. If a robot runs into the guiding line again, and at a point which is closer to the exit, then stop and follow that wall yourself until you get there too. Keep following the line and repeating the process until the end is reached. If both robots return to the original locations and directions, the farther points along the line are inaccessible and the maze is unsolvable. Unsolvable for your solution, right? Or no. No, yeah, it could still. Oh, no, he's right. Wait, that's so cool. Okay, we might need to look into this. Recursive backtracker. That's depth first. Trimute, no. Right, I'm pretty sure. Find a solution for all mazes. As you walk down a passage, draw a line behind you. Hit a dead end, turn around, and go back the way you came. When you encounter a junction you haven't visited before, pick a new passage at random. If you're walking down a new passage and encounter a junction you have visited before, treat it like a dead end and go back the way you came. If walking down a passage you have visited before, any new passage if one is available. Otherwise, take an old passage. All passages will either be empty, meaning you haven't visited. Okay, that's cool. Dead end filler. It's always very fast, uses no extra memory. Just scan the maze and fill in each dead end, filling in the passage backwards from the block until you reach a junction. That includes filling. Okay, I can't just. Okay, no. Old stack. Maze consisting of blind alley system, single loop, dead end filler. Focus on the maze. It's always fast, uses no extra memory. Scan the maze. No, I'm not scanning the maze. It's all possible solutions. No. Line, no. Shortest, no. Short, no. Collision solver. Amoeba. This method will find all shortest, no. Random mouse, no. Solutions. All one. Guarantee, yes. What? Excuse me? This is where algorithm is guaranteed to find at least one solution. Dead end filler isn't. Blind alley, collision. Chain is the one that I was interested in. Focus, U plus. Two general types, focus on U or focus on the maze. In a U focuser, you have a single point or set of points. Try to move through the maze from start to finish. Can I do chain algorithm without two robots? I should be able to, right? Human doable, no. Passage free, yes. Memory free, no. That's fine. Fast, yes. Source, okay. It's got to be fast. It's got to be. It doesn't have to be memory free. Passage free. Whether the algorithm can be done anywhere. Some algorithms require the maze to have obvious passages or distinct edges between distinct. Yeah, I'd rather not it be passage free. Okay, this does have to be passage free. What does that mean? Like, I don't. Human doable, that's fine. Focus. I don't know. That's good. Solutions? Okay, good. Yeah, that's fine. One solution is what I want. So either chain algorithm or Manhattan distance. I think I want to try Manhattan distance. Other maze operations, flood fill, isolation remover, loop remover, bottleneck finder. Means to find those passages in a maze such that every solution the maze passes through them. No, I don't care about that. Labyrinth? What is this? List, Labyrinth, Oracle, Maze Maker. Maze Maker. Playlist. Cool. Who is this? It says you're a person number 728,000. Cool. Damn. Walter D. Pullen. Who is this? Wait, what? Oh, email? Magitech. What? Chi generator? What? Okay, I need to chill out. Maze solving. Okay. If I want to try chain, let's do Manhattan distance. Let's see if just this one um Wikipedia page is enough for me to use. Wait, which was it? Pledge Manhattan distance. Then filling cursive. When was it? Maze routing. Man, yeah, okay. Maze routing. Um, yeah, let's do this. So use the notion of Manhattan distance relies on property of grids that the MD increments decrements by 1. Yes. Perfect. This is exactly what I want. So while wait, what is cur? Current location is not equal to destination. So while okay, if there exists a productive path, take the productive path. Productive path is one that makes our MD to distance smaller. Okay. Let's implement this. You know what? Let's just implement it as I read. If there is a productive path, make that path smaller. First, actually, I'm going to make a new thing called Mazes Plus, just like my Pumpkins Plus, except I never made Pumpkins Plus. I just have an idea for it. Mazes Plus. That I can't not do this. Sorry, 1 second. If um, name is equal to main, I can't type with this in my face. Yes. Um, mazes main, except that's already well, whatever. Um, maze 2 main. And fine, I'll call this mazes 2. But then that's confusing because I have maze main 2 and maze 2 main. Okay, whatever. And then we're going to have maze 2. Sorry, I'm forgetting how to Python. Okay, maze 2. What do we need defined up here? Point. So it needs to, well, it needs some of the things that I need from the other maze. Let me actually take this down. Lib, put that at the top. Cacti, mazes, sunflowers, sure, whatever. So I can look at this from lib. I am going to want that actually. From lib, import. Okay. And then I just want this. I'm just going to take, yeah, I'm just going to take this. And then we will, of course, make it how we need it. Okay. Let's go ahead and get rid of that. Wait, what is this called? Maze main. Main maze. Main maze, maze main. Okay. Main maze 2. We're going to do. Main maze 2. Okay. And then I probably need directions. Well, I'm just going to be lazy because I already did it. With that. Okay. And then do I need anything else? No. Okay. Maze 2. Def maze 2. Let me make sure this is how I want it. True, clear, plant, bush. Right. No. Um, we're gonna clear once, but after that, no. Plant, use item, weird substance. Okay. For direction and directions. Actually, I'm gonna delete that as well. I'm just gonna run maze 2. I don't know if that's how that works. Okay, let's just put that down there while I code this. Point source distance, source and destination coordinates. Source and destination coordinates. Blue code. Oh, okay, that's. Wait, I'm sorry. How do I get point source distance? Source and destination coordinates. Um, size. Okay, directions. Yeah, whatever. While true, plant use item. Get. Okay, I need. Oh gosh. I should have this. I just need to do this. Hold up. F make maze. Yeah, I'm just gonna this real quick. Not that. Not that. Not that or that. Not that or that. Sure. Yes. For now. Now in here, I'm just gonna have this make maze. Now that we're in a maze, okay, we need MD best. Stores the closest MD we ever had. Okay. Point source distance. Source and destination coordinates. Source? I'm sorry. Source? Source? What is source? In addition to finding paths between two locations of the grid, the algorithm can detect where there is no path between the source. Oh, source is our position. Got it. Source is where we are. Destination is where we need to be. Okay. I can do that. Um, size. Yeah, let's go ahead and get rid of that. So, what was that called? Point equals source. Sorry, point source destination point. I don't point. I'm gonna do um, position equals get pause x get pause y and um, and then run it because I'm scared. How does this work? Uh, 1914. Okay, good. And then I'm gonna do. Um, wait, so what is that? Type? What? Type isn't a thing. Okay, whatever. Um, I don't know why this is so difficult for me. Make maze position, and then goal equals measure. Okay. And that returns a tuple, correct? Man, I'm rusty on my programming. Measure transposition. X, Y equals measure. Um, print. Oh, gosh, this is ugly. Make maze? What you mean? Oh, gosh. 6, 0. What is this? Just a weird substance? What is the exact number? It's world size times 2 to the power of num unlock of mazes. 6. 2 to the power of 6. Okay, hold up. Do some math. Wait, I could just do it in there. I want 6. 2 to the power of 6. 6. Is this gonna make you happy? Good. 5, 3. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3. Good. And my position is whack. 2, 4, 0, 0. 1, 2, 1, 2, 3, 4. Good. Okay. Now what? Now MD best. MD of source and distance. We can do that. MD best. Except this is not Java, so MD best equals MD of, go ahead and def MD, just gonna take, I don't want to use the same, I'm gonna say this is treasure now, and then MD position treasure, and this is, I'm gonna do, fuck it, I'm just gonna do SRC and destination. And then how do you calculate that? SRC, is that just, fuck, how do you calculate it? Spell it to me easy. Give me the formula. It's simple, isn't it? Two-dimensional coordinate space. Taxicab distance between 2 points, x1, x, x1, y1, x2, y2 is absolute value of x minus x2. And okay. Manhattan distance. Good. Can I just take this? You mean, can I have this? Do we have absolute value? Operators wouldn't be in here, would it? Comparison. Where would it be? Programming, debug, comments, continue, dictionaries, for loop, namescope, sets, operators, lists, import, if, functions. variables. Wow, how do absolute, oh my gosh. Just give it to me. Is that a thing here though, is what I'm wondering? Oh, it is. It is. Good. Oh, good. Okay. Sorry, C 0. Goodness. Goodness. Minus DST 0 plus this of the other one. Does that work? Okay. We're gonna print. Um, what? What do you mean expected a comma or close? Oh, no. 8. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Do it again. 1, 2, 3, 4, 5, 6, 7. Beautiful. Do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. That works. Now what? Okay, right. While current does not equal destination. We're gonna instead of that, we're gonna do while get entity type does not equal entities dot treasure. That should be the same, but in Python and Farmer, there exists a productive path. Take the productive path. How do I do that? I understand this. I don't think I can know if a path is productive unless the path, unless I do that, unless I go there. MD best else MD best equals current. Imagine a line between current and this. Take the first path and in the left or right of the line. The left slash right selection affects the following hand while MD current best is not equal to ooh, okay, this is it. Well, Manhattan distance of where we are after moving is not equal to the one that we've had. There does not exist a productive path. Okay. Follow the right hand slash left hand rule, the opposite of the selected side of the line. I'm sorry. Um, take the first path. What do you mean take the first path? Yeah, I'm gonna need a bit more than this. Yo. This is it? This is all you're giving me? Wait, no. No. What? But like, how do I do that? Take the first path in the left slash right of the line. Wait, shouldn't this be recursive or something? Like, wow, okay. If there exists a productive path. Is that what I need to figure out? Let me try and do this. If there exists a productive path. So let's do if productive path. What? If productive path what? Take the productive path. No shit. Um in order to know, I need to have okay. I need to have something here. Um productive path that takes in no, it doesn't need anything. Productive path, and it gets the position. And actually, this needs to be updated in here, doesn't it? Wait, it does, doesn't it? Yeah. No, definitely. Um, let's just put it here, I guess. No, it can't be there. Gotta be after. Whatever. Okay, but find the productive path. If productive path, how do we find that? This is the position. We need to move in a direction and check if our MD is better or worse. If the movement works, if the movement doesn't work, it won't get better. So we'll just continue. Okay. Okay. Hmm. Do we have directions? Yes, we do. Okay. Oh, this is annoying to think about. Productive path. So MD, is that what I'm doing? No, that's not what I'm doing. For direction in directions, move direction. No, not directions. Move direction. Now, if MD of I need to get position. I need to have a thing called get position. Get position. Yeah. And it's gonna return get pause Y, get pause X, comma, get pause Y. Okay. And then that's what this is gonna be. Position equals get position. And then for here, we're gonna do if get position. So I don't need that. If get position and I do need a variable. DST, sure. And DST. So in here, if productive path pass in DST, right? That does exist, doesn't it? No, treasure, I mean. Goal. Well, it's freaking goal. Okay, goal. 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 Position. Goal. Also, position equals get position. Actually, I don't need. No, that's not useful. I just need to have it here, don't I? Yeah, okay. Goal equals measure. MD, get position, goal. If productive path of goal, right? Okay, that's what we're doing. So move this direction. If MD, oh, I need previous MD as well. Um, shit. Um, productive path. So it needs to pass in goal and MD best, right? Or just current MD. No, 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 no. It needs to get MD. I'm tweaking. I'm tweaking. If MD of this, oh, it needs to do this. Cur. Wait, cur. What is cur? Cur. Productive path is one that makes our MD. Huh. As close as MD we ever had. Source. Source and destination. Cur. What is cur? Am I blind? Cur. Where are we? Cur also indicates. Okay. So I am blind. It says it right here. Literally right there. Indicates the coordinates of the current location. Cur is not equal to this. What is source then? Source and destination coordinates. If cur is the current location, what is source? I thought source was the current location. Source and destination coordinates. Source. Because it's what? It's returning the path? And, okay, wow. It's not, there does not exist. Or there does not exist. Follow the right hand left hand rule. Yeah, what is that? I feel like you're skipping on me. One effective rule for traversing mazes is the hand on wall rule, also known as either the left hand rule or the right hand rule. If a maze is simply connected, that is, all its walls are connected together. Wait, it needs to be simply connected? Maybe I need to watch this guy's video. This one. He does Manhattan distance in here, doesn't he? But it's 2 hours. First algorithm is a depth first in order tree traversal. Algorithm is a depth first in order tree traversal. Maze is simply connected. Left hand or right hand rule. Multiples are connected together and maze out and everything by keeping one hand. A different exit if there is one. Otherwise, the algorithm will return to the entrance having traversed every corridor next to that connected section of walls at least once. The algorithm is a depth first in order. Is not simply connected. This will not necessarily reach the goal. Taken to begin while following the entrance of the maze. Uh-huh. Any two locations. Usually proposed for chip. Any grid-based maze, defining paths between locations, can detect when there is no path. Algorithm is to be used by an inside traveler with no prior knowledge of the maze. Fixed memory complexity regardless of the maze size, requiring 4 variables in total for finding the path. I feel like this wasn't a very good. Okay. I need a better source. No, not A asterisk. Do I need A asterisk? I don't want to find the shortest path. I just want to find a path. Uh, shortest distance to the exit from every point. What is this? Image processing. No. No. Breadth first search versus A with Manhattan distance. The maze. Single final state. Sign a maze in which breadth first search expands less nodes than A. Possible. The intuition is your heuristic is more informed than BFS. I need to learn A asterisk. A star. Why did I hear so many people call it asterisk? Okay, A star, sure. Highly used in robotics, video games. Okay. Finding the strengths of dexterous and greedy best first search. Heuristic to estimate the cost of reaching the goal from a given state. Ah, representing them effectively is crucial for implementing algorithms like A star. Common 2D grid, yes, okay. These can have intricate layouts, dead ends, loops, alternative paths. Navigate through this complexity to find the shortest route. Each cell in the grid represents both the walls and the steps. So when you move from one cell to another, you skip a cell and then the actual movement occurs over a distance of two cells in a horizontal or vertical direction. Odd cells 1 represents the wall, 0 represents the passage. Even cells represent the walls between the cells of the labyrinth. I don't care about how to generate a maze. Components of A star. Okay. Typical implementations of A star use priority queue to perform the repeated selection of minimum estimated cost nodes to expand. This priority queue is known as the open set, fringe, or frontier. At each step of the algorithm, the node with the lowest value is removed from the queue. The algorithm continues until a removed node is a goal node. Take a look at the pseudocode. A star, start, goal, H. Sorry, H. Discovered nodes that may need to be reevaluated. The set of discovered nodes. Initially, only the start node is known. Okay. Usually implemented as a min heap or priority queue rather than a set. Node in came from in is the node immediately preceding it on the cheapest path from the start to in currently known. Came from empty map. For node in, G score in is the cost of the cheapest path from start to in currently known. Okay. G score map with the default value of infinity. G score start 0. For node in. Yeah, you're losing me. What? Remove current. Open set. Open set is not empty. Cost function in, which encapsulates both the actual cost and the heuristic estimate. It determines the priority of a node in the exploration queue. Nodes with lower total costs are explored first, fostering an efficient search process. Total cost Gn represents the cumulative cost from starting node to current node. See, what is this? This is about finding the shortest path. What about solving? Because start goal H. Only the start node is known. Like I'm with you until here. Like I'm with this. This is good. And here I'm like, what are we talking about? Open set. Start. What it I don't like your pseudocode. Isn't the point of pseudocode to be simple? You don't have to use like okay, whatever. I'm sorry. I shouldn't be upset because I don't understand. It provides an informed guess about the remaining distance. Effectiveness relies on the choice of heuristic functions. Stability. Consistency. Solving maze. Find the optimal path from start to the goal. Based on previous pseudocode, a Python implementation could look like. Okay. Okay. G, dictionary, start node, tuple, indent, full node, tuple, indent. Okay. List. None. Yeah, I don't know Python well enough. Open set. 0. Commonly used heuristic for maze solving in the is the Manhattan distance. Def heuristic. Tuple. Goal. Okay. Why is it called heuristic? Why isn't it called get Manhattan distance? Okay, I'm sorry. It's fine. Cost so far. Why are we using words like cost instead of distance? Or I don't know. Okay. Came from. Open set. Rebuild path in. Return none. Rebuild path. Where are we using rebuild path? Rebuild path here. Goal path equals rebuild path. P equals n, while in came from, n equals came from in. P dot append in. Return P. Goal path equals rebuild path. Return goal path. Why don't we return rebuild path? I'm confused. This is stuff that I don't understand. Goal path equals rebuild path. Return goal path. Why don't we just return rebuild path? Why why does goal path exist? Because this is returning a list? Okay, my bad. It's something like that. While length open set is greater than 0, that starts at 1. If current node is equal to goal node, goal path equals rebuild path. Okay. If not, for neighbor in G current node, G of current node, new cost equals cost so far dot get current node plus 1 cost so far. If neighbor not in cost so far or new cost is less than cost so far of neighbor, cost so far of neighbor equals new cost. Nah, nah, nah. I think I'm thinking about this on a different level. Like this is just a level above because I'm thinking about this in terms of like, all right, I need logic to figure out which direction to move and seeing my distance between, but instead of that, it's this and there's no like go north or move anywhere. It's just all words that I don't understand. Heuristic. Used it one time. Heap pop open set. I just don't know Python well enough to read this, I think. Returns the list of nodes that make up the fastest path. Starting from the initial cell reaches the final cell. Red dots are the explored cells, red dots are the current optimal path found. Well, why? Hmm. I want to see it branch off into two. Yes, this is what I want to see. What? Mm-hmm. Uh-huh. Because it's looking for the optimal path. Once it finds a path that is longer than the other way, it says, okay, well, there's no way that this can be optimal if the other way is only one step away. So let's check. And then it does that and says, okay, well, this isn't for sure the optimal path. Let's check the other one. Okay, so that makes sense. It's not making sense here. Is this? Is this that? Like, is this really? Because doesn't this include like I don't know graphics? Like how does the like I want to see how you made this. I don't think that this is all that you did to get this. I don't believe it. That's like I know I'm not the best at Python, but like you're not doing you're just doing calculations here. You're not like calling anything that does anything. That's what I'm missing. That's why I'm so like what? Okay. Find the shortest path. There are several algorithms. Okay. Man. At this point, I'm thinking I just need to watch this guy's video. Heuristic technique. Breadth first search algorithm uses a queue to visit cells in increasing distance from the start until the finish is reached. Each visited cell needs to keep track of its distance from the start, which adjacent cell nearer to the start caused it to be added. Finding an algorithms. Hmm. I think I need to play a video game because this is freaking me out. Hmm. Huh. E-star. Pre-related implement any one of them. Original D-star informed incremental search algorithm. Heuristic search algorithm. Light. Hmm. All right, chat. Help me out here. What maze solving algorithm should I learn to use in a setting where I am um I need to Find the treasure in a maze. In a single maze, but the position of the treasure changes each time I find it, and walls of the maze are removed at at random each time. I hope that it realizes the question I'm asking is not to explain. I just want to know, what maze solving algorithm should I learn to use? Maze changes over time. Yes, I know. It's interesting. Dynamic environment. The goal moves. The maze layout changes. Yes. Algorithms like depth first search, breadth first search, or A star, which assume a fixed map, aren't ideal. Exactly. Especially these first two. This one might work if I understood it. Have I already solved basic mazes before getting walls removed? Oh yeah. Yeah. I mean, we could do this all day. In fact, if I'm gonna run it, which I should be running it while nothing's running. Um, yeah, we're chilling on that. I'm trying to do literally not useful at all for like the actual game. I have 100,000. How much do I actually need? A million? 100 million? I could let this run overnight. I'd be fine. I just want to get the 300 with a full size maze. I know that I could do one by one maze 300 times. I just am interested in learning maze solving algorithms. So I don't have noise. Where is it? Oh, we're here. Nice. Yeah, I did that, and then I've been looking into. I looked into a few of these a bit too much and started writing, um, and have decided that I don't think I can understand it with the way that this is working. So I started looking just for another way to get this explained to me, and I found other things that weren't more helpful. So I'm just seeing if I even have the right approach. Um, my method for basic maze solving. This is recursive. This is just a recursive out. I don't care about this. Um, okay. What? What? What is the error? What? Okay. Recursive. So directions. This just returns the opposite direction. So north goes to south, south to north. And then this is just making the maze. And this is the whole thing that solves each maze. For direction and directions, if maze and direction is true, break. Um, and so that goes to here, calls maze direction. And then if I can't move in that direction, it goes to the next direction. If I'm over the treasure, it leaves. And then if neither of those are true, then it tries to move again. Um, and it just calls itself repeatedly and finds it. I'm not a good person at explaining it. I can show you the video where someone else explained it really well if you want to see, because it's not my own. I didn't come up with it, but it is really nice. I could just stop here. It would be so simple. It takes a long time to find it though. It's just because it's so big. This is pretty um efficient, I think, unless it happens to be um here. Actually, I'm about to find it. There we go. How does it break a wall when it gets removed? How does it break when a wall gets removed? Oh, I see. It gets stuck in a loop. If I edit this, no, okay. But let's see how far it gets actually. Instead of harvest. Wait, where do we harvest? It's here. Turn true. Wait, I'm not harvesting? I haven't been harvesting. What am I doing? Um, oh, I just deleted it to, okay. Yeah, so instead let's not return true. How's that? How's that gonna work? Yeah, let's just do use item size and then declare this out here. That's a good question. Let's make it smaller as well. Um, well, this is gonna wait. Why is it harvesting? You see that? It's harvesting. Why is the maze changing? Also, the walls aren't removing. Why aren't the walls being removed? Oh, well, the walls were being removed, and as you can see, it's stuck in a loop. Some way to identify if I've already gone over a certain path before, and if I have, try a different way. Yeah, yeah. I need something that's more like real solving, because what this one does is it just moves wherever it can, and it doesn't have the problem of looping back on itself. But I need something that actually like maps out what's happening and understands a lot better. This wasn't built for resetting, so it's probably just something I have wrong in the while loop that's resetting it, but this is a good example. Maybe if I start it like anyway. I honestly have no clue um what I'm doing to make the other way. Dynamic incremental pathfinding algorithm. Yes, I want it to be incremental. I was trying to use Manhattan distance for one, and I couldn't get a good source to understand it. Like I feel like that or something like that should work. I just don't have a good understanding of how it works right now. D dynamic A star. That's not what D stands for. Okay, D star. Designed exactly for this type of setting. Is that what? Okay. It updates the shortest path when obstacles appear or disappear without recalculating everything. So what? I should learn D star. If you're doing this in a game or simulation, D light is usually the sweet spot. Handles moving goals and map changes efficiently and works well with grid-based mazes. Good. How to learn D. Okay. How it conceptually works. I'm really scared to learn new concepts from ChatGPT. Existing maze solving algorithms is only going to make this harder for you because this is a more unique problem. Think about what I'm trying to solve. Come up with my own algorithm. I like where you're thinking. I like where your head's at. So, hmm, okay. It's gonna be a lot of me sitting in silence now. What I was thinking before is it's just I know that my solutions are so like inefficient, I think is a good word. But I do hmm. I have a really weird way that I think I could get to work. I just didn't want to try it. Oh gosh, this is so annoying because it's northeast first. It's just gonna search the entire maze before it finds this. That's also a reason why I thought depth first search might be better. Wait, no, I'm doing depth. Wait, it's breadth first search. But anyway, so you're okay. You know what? Let me, yeah, let me take all this and get rid of it. Okay, you're right. You're right. I'm gonna keep this, but everything else starting from scratch. So basically, I want to have a list of coordinates. Oh, this is so weird. I know. Okay, I'm just gonna. You're right. I'm just gonna do it. So, um, it's world. Gosh, it's so far down now. Okay, and actually, I'm gonna do this. Interesting. So, I just want to loop through every coordinate and add it to a list. Oh my gosh. Okay. What's this? Just chords, all of them. Python is too simple. Um, append. Wait, I can just do plus equals. Can't I? Is this how this works? Oh my, I haven't learned Python in so long. Wait a minute. Chords dot append. Sure. Append I j. Would this effectively give me coordinates of everything? 60, it goes to 31. Yeah, let me just got the exact syntax. I can always try things out. Yeah, yeah, you're right. Print chords. Also, where's my output window? Sets, import, dictionaries, operators. Wait, don't I have debug? There we go. Output. Takes two arguments. Append takes two arguments. I'm sorry. Didn't I? Is this not two arguments? Wait. Oops. Truncated output 0001. So this is not tuples. Um, This isn't tuples. I want tuples. Is it? Is it just printing weird? No, it's just not. If cur equals ij, well, this I think I should just look up the syntax because it is getting everything, but general info cold output. Okay, yeah, I did. Oh yeah, maybe append the tuple. Nice. Okay. Um. So with this, what am I doing? So wasn't there a way? Gosh, it's been so long that I could do this in like in here and it would whatever. Wait, I can't. I'm gonna ask ChatGPT. Hold up. This is just out of my own curiosity. I swear I'm not cheating. Yeah, this. For I in range, for J in range. This is the same thing. I just think that it's better. Oh, it's really big. Whatever. But oh, does it not actually work? Okay, never mind, never mind. I knew that there was a way. I'm just gonna keep this way because this isn't a normal ID. Now that I have this, I'm gonna have another one, and this is weird, but I want a way to figure out which coordinate I'm at. So in or chord in chords. Yeah, yeah, I remember. For chord and chords. Also, out of curiosity, have you um played through this whole game? Like, what brought you here? Just wanted to see someone else struggle, or okay, but chord and chords, and right. Let me actually get the def get position uh turn get x get pause y fit check. Oh, what's up, Vix? How you doing? Okay, I'll do a fit check in a second. Got to end game before the 1.0 release. Haven't had a chance to play it again. Nice. Yeah, good to see you, Vix. I popped in your stream the other day at 3 a.m. right after you left, and I redeemed Hydrate. I don't know if you saw that, but okay, fit check. This is not good. I'm gonna be real. It's been a lounge day. I was supposed to work, but I didn't. Um, Black shirt. We got the like beach USA trousers and some gray socks. Lame fit, but cool game. No, yeah, Jeff, this is a really cool game. I played it before 1.0. All I did was up to pumpkins and I got a really nice pumpkin, which actually we should have something running in the background. Oh, but I can edit, can't I? Yeah. Yeah, let's have these guys planting pumpkins while we're off to the side. Except he's going to catch up really quickly because oh yeah, now it's ugly. Oh, wait. It's actually pretty cool how that ended up working out. Okay. Anyway, um, recording chords. Actually, I want to make this a function as well. Well, whatever. For recording chords, um, if get, sorry, no, position you. Thanks, Vix. Get position is equal to chord. Let's just print chord. So I'm actually going to need to not be making pumpkins, which is sad, but well, I already okay. I just want to run this. Ryan range. Okay. 1121. Is that true? 1120. Yeah, that looks true. Okay. So it did that. So now I'm going to make that a function as well, actually. Um, I can't put this before this, can I? Chords. Def. Okay, well, that's fine. Def. Um, Fine chord. Sure. And this is going to return chord. So now, what am I doing? Right, solving a maze. I think I'm gonna use this algorithm that I already have. So perhaps I should just move this stuff into there. Um, and remove this. Okay. And also just move some stuff around because I want it to be pretty. It's not that pretty, whatever. Get position, find chord. So now I want to basically assign every place, um, every spot on the map. Which, you know what, I need to just um, reset position and plant entities dot push and use item weird use item items dot weird substance 192, please. I didn't plant because, you know, let's just do a clear. Okay. So I can visualize what's happening a little bit better. Um, Honestly, I want to run the same thing, I think. So for oh well, actually I can just do left hand or right hand in that because what I'm just trying to find every spot in the maze. And that effectively does that. But then that's not what I'm looking for. Ooh. What if I had this is weird. Oh man, okay, I'm feeling it. So north. Actually, let's do um wall north and then east, south, and west. Now, let's do quickly. And actually, I changed my mind. Um, I should have just started with this, but I want this stuff to be somewhere else. Maze direction and opposite direction. I want it out of my way. Okay, this is fine now. But it's not a valid expression. 4. Right. I'm just gonna make, well, let me put this away. Left hand. And then I'm gonna store at each position um, where the walls are. And then I think using that, I can figure out a way to get from point A to point B. And that's all I really need. So, position, find chord, def, discover. It should start, and then we call that here, discover. And then we'll have another function that goes, that's go to. And then that takes in, well, we don't need to, we can get the current position once we're there, but the coordinates that we want to go to, x, y. Now, discover is going to be the simple, actually, is this just using my previous algorithm? What does the maze left algorithm look like? Or follow left? That's here, isn't it? All walls, one large connected wall, follow the wall, lead you through the whole maze. Yes, yes. Instead of moving the drone in absolute directions, move the drone in relative directions, turn right, turn left. You just need to keep track of the way it actually rotates, virtual rotation encode. Right, I can do it with that. Awesome. Turn right, I see. What is the modulus for? Wait, no, seriously, what is the modulus for? Oh, okay. Yeah. Show him 4, isn't that? Yeah, okay. So, let me do that. I already have directions, so I can do, um, wait, actually, let me pull this back up. Uh, yeah, index 0. I'm gonna do that. Discover is, wait, isn't there, what's this? Can move. Yes, okay. If if can move, um, directions at index, right? Then move directions index. That seems too, like, too much code. Can't I just do if move? Yeah, wait. If move, if not move, but If it does, then it will move. If it doesn't, then index plus equals 1 modulus 4. Wait, how does that work? Index equals index plus 1 modulus 4. Okay, it does. It can't be plus equals because it needs to be like this. Okay. So I don't need. No, that's stupid though. Because no, what I should do is I should just, if can move directions index. Wait. Oh gosh, I'm thinking about this way too hard. I feel like turning left and right should be the easy one. While true. Um, I'm just gonna do if can move directions index move directions index, and then else index else index equals index plus 1 modulus 4. So this is going to move. Okay, no. So then move. Okay, no. So then move. This is going to go in a circle, is it not? That's not enough. Um, no, yeah, it needs a little bit more logic than that. I think that I'm tired or something because this is really simple, is it not? Uh, yeah. Sorry, I don't know when you said that, Jeff, that the modulus will wrap around because I um, understood that shortly after asking. Wow, has it really been this long since I did a coding challenge? I just like can't focus. Okay, forward, forward, good. Can't move, turn right. Can't move, turn right. Forward, forward, forward. Can't move, turn right. No, I need to check each direction. Wait, for direction in directions if can move um no, if can move direction, move direction. Wait, I'm just making the one that I already had because now I'm going to say not. This is literally, oh my gosh. Why is this so hard to conceptualize? Conceptualize. Conceptualize. If not can move direction, continue. Wait, this is, I'm literally, wait, am I not literally writing the one I just had? If not, return false. Oh, okay, I need to stop thinking so hard. Direction and directions. 4, 8. Sorry. Um, this already does what I want. This does exactly what I want already. Right? Isn't this exactly what I'm trying to do? I'm spending so much time trying to do something else, but I can just do this. Hold up. Maze direction, opposite direction. Yeah. So let's do in Discover. Let's do uh, wait. Yeah, for direction and directions. Maze direction. And I'm just going to make maze direction. Oh, yeah, I need this to be afterwards. Well, not that. Get position, find chord, discover, go to. This is going to be working in Discover. Um, and then how is this working? Right, okay. In Discover, it's going to be um, for direction in directions. Um, wait, no, where is it? Yeah. If it's the opposite direction, if opposite direction is equal to direction, continue, else, or just continue further on. If explore path, explore direction, true. Except I don't need that. I just need explore path, explore direction. Um, maze direction. What does this do? What did you do? Oh, right, because it's no. Um, clear plant discover. Discover does this. Direction and direction. Wait, what am I doing? I'm forgetting. Forgetting how things work. Oh, it needs to be here. Sorry. For uh, direction in directions. Maze direction. Why did you harvest? I didn't think you were supposed to harvest. Oh, because I didn't. Okay. Let me get rid of that. What? Clear plant use item. Oh, I don't have any more weird substance. Hold up. Um, I need to harvest some weird substance real quick. Does this not have multiple? No, this is an old algorithm. I completely forgot that I even needed to think about collecting weird substance. Okay, that's fine. Yes, this explores every path and then stops when it gets here. So at each position, right, I want to check where the walls are. Is that needed? Is that necessary? Yeah. This is just super, super like basic, but it'll work, won't it? Okay. Okay. So discover where is move. Um, move. If not move, okay. So instead of if not move, return false, I'm gonna do if move, else return false. Because I want, wait, actually, wasn't it just right here that I can do that? Yeah, I need to do it just here. Okay, I don't need to mess with that. If not move, return false, because if it'll just return, so it won't get to here unless we're in a new spot. So here I need to go um, get position and chord. If get position is not, wait, chords. Chords. No, that's not what I need to do. How do I search for the index of a specific coordinate? Find? Is that a thing? Stop. Remove, insert, add, pop. Um, what am I thinking? Um, I want I want a function that, given the position, find chord for chord and chords. Oh, find chord. I did this already. Find chord for chord and chords. Find chord. Hmm. Okay. Yeah, I did this already. So find chord returns the coordinate. I want it to return the index of the coordinate. So I'm actually going to do just I here for I in length of chords. That's, does it show me? Oh, that is so nice. Oh, it takes one tick to execute. I didn't realize this stuff did that. Anyway, I'm not really worried about that. One tick, doesn't planting take 200 or something? I don't remember. Okay. I in length chords return I. So I'm actually going to change this to find chord index. And now it's going to, every time we move, it's going to, actually, I need another function. Check walls, right? It's just going to take in, doesn't need to take in anything. No. Oh, but it is really weird. No, no, it's fine. It's fine. Oh, no, it's weird. because they already have, chords already has, they already have indexes. Chords needs to be empty. Yeah. Yeah, that's what I'm figuring out. Chords doesn't need, that's fine. So actually I need at every spot to and actually in here I can have if get entity type is equal to entities dot treasure, not collect, not harvest, but do we have size? um I'm not using index either. Size equals, right now it's going to equal 192. And then here we're going to do size. Here we're going to do, I'm just going to use item substance size. So that's good. Return false. Okay. Every time we're at a new spot, we need to run check walls. Actually, I'm just going to turn this into check. Or actually, check walls or set walls. Set walls. Sure. Doesn't matter. Doesn't matter. This is names. Okay. So I'm gonna do, and also this doesn't matter anymore. I don't think. I'm not gonna delete it yet, but I don't think I need that. So, okay. Ha 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 ha. Before I move, like right here, right? Set walls. So here, what I'm doing, gosh, this is so weird. Okay. Plus equals, okay. North value, north n, nv, EV, SV, and WV. Yeah. So here, I'm going to have, yeah, no, this is simple. This is very simple. Chords, um, dot append, or actually, right, we just learned that we have to do this differently. Cur equals get pos x, get pos y, append cur. Cur. Right? Now, wall north, all of these. It's going to be plus equals what is it? Can move mazes, harvest, move, can move, checks if there's a wall. Can move north. North. And that's what all of these are going to do. Well, not all for north, sorry. East, south, west. So what this is going to do is every place that I visit, it's going to keep track of the index of where. So basically, now index one or index zero is going to say, okay, at this spot, you can go north and east, not south or west. And then next time I go somewhere, it's going to say, okay, at 0, 1, you can go east or south, not west or north. At 1, 1, you can go north and west, not east or south. So, east or south, whatever. I don't think that this is the most efficient. I know that this isn't the most efficient, actually. However, wait, can I do this in 3 lines? I would have to make another variable with these in them. Could. Nah, shouldn't. No, I won't. Okay, that's pointless. Let me just try and get something done. If not move direction, if maze direction, if not move direction. Okay. So I'm running it once here, and now I want to run it once here. Set walls. And then, well, actually, I want to remove this temporarily. Once you do that, I want you to simply print a few things. Print chords of, I don't know. Let's do like chords 10, right? And then also um, walls north. Is that what they're called? Wall north. Wall north 10. And then also the other 3 directions. Wall east 10, wall south, wall west. I just want to see. Error. Plus equals. Try to read the variable wall north before a value was assigned to it. What do you mean? Wall north is here. I see. Well, how do I do that? Can I just do dot append? Excuse me. Yes, okay. I can just do dot append. Plus equals works later on, doesn't it? But it's not here. Sorry, I'm not up to date on my. Now this goes through everything in the maze, and then false, false, true, false. At 10, what is 10? 10 is 3, 3. Let me just check. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yes, yes. 3, 3. Exactly how we wanted it. And it is false, false, true, false. Beautiful. Okay, that is working as intended. Now, I need a discover go to. Now, this is going to work on way too much logic that I don't think was necessary or is necessary. But okay, how do I think about this? So, what I want this to do is take the current position that we're at and the position of And actually, I don't need this either. This should just be called go to plus equals for when you want to add all the elements of one list to the end of another. Oh, right, because that we can use that in like printing or other stuff. Okay, you're right. That makes sense. Go to treasure. So I don't know if this was necessary. Well, I sorry. I know this wasn't necessary. I just felt like it would help me. Um, but why? Um, I don't know. Using this information, or the information I've gathered allows me to traverse the maze without needing to l- look at the maze. But I don't need to do that. That's not. Was this helping me? This isn't helping me, is it? I think I lost my train of thought that led me to do this. This is cool though, right? This is I have a list of um I can access any position and know where there are walls and where there are not. That's helpful. Here, I know that there's not a wall here. Ah, yes, this is why it's useful. And here, I know that there's not a wall here or here. So now I can check here. There's not a wall here. Here, there's not a wall here. Here, there's not a wall here. That's a dead end. Go back. Here, there's not a wall here. Here, there's not a wall here. Here, here, here. So I can trace. Except I, I can't really. Oh, wait. Oh, I'm seeing it now. So what I can do is instead of appending every position I haven't been to, I can I can do that, but then once I backtrack, I can remove it, can't I? And then I'll be left with the path to victory. But wait, that doesn't help though, does it? That's true. That doesn't help. Hmm. Hmm. Hold up. I have the position of treasure. 5 0. Okay. Straight line. I already had that. That was Manhattan distance. If it was here, I would just draw this line or okay. But now I know there's a wall here. I know that ahead of time and I can use that information to draw the line, right? Right? Go to treasure. Hmm. No, this is good cuz no, wait, this is good. This is good. This is giving the drone. Oh, yes, this is my oh, I remembered. I'm so glad I remembered. This was my train of thought. This coordinates and whether or not there's walls is the only difference between what I see and what the drone sees because the drone doesn't see, right? But given this, we can apply the same logic that we use to go, oh, obviously you have to go here and that's the path. We can we can give the drone that same logic, right? Right? But how? I need a path. And then find chord. Find chord. That's why I have the find chord. Um, and actually, this would be cooler. It was like this, which is how I'm going to do it from now on. That way it's just find index and not find chord index for the super specific example, even though I don't need it for anything else. Find index, right? And index of chords. Wait. But it did need that, didn't it? Find index list. Yeah, what am I thinking? What up? I'm tweaking. Where is it? Oops. What did I delete? Treasure. Right. I did one too many control Z's. This needs I equal in length chords if get position. Oh, if um position. So this takes in position. And so find chord index of measure gives me the index in our chords list of the position of treasure. And using that, Manhattan distance. Oh my gosh, Jeff, I'm out. I'm on it. I'm on it. I feel it. I feel it. I need Manhattan distance. And that's really easy, isn't it? Um, Manhattan distance, but I do need um, well, wait, I'm calculating. Yeah, yeah. Um, I need two positions, don't I? Oh no, I Manhattan distance from drone. So using this, I can calculate the shortest path. So okay. Oh, I've got it. Oh my gosh, Jeff, I have it. This is this strategy is going to work. However, it is not going to calculate missing walls. Like if I am doing it and then I need to get through here and this wall has been removed, it's still gonna go around. But I have the idea. Oh my gosh, Jeff, I'm so thankful because this isn't even like crazy. This is just this makes sense. Okay. I haven't explained anything. I think um I don't I don't know how to. And also I have plans in a little bit. Um so I'm really sorry that I'm not going to be able to finish it. However, um I okay, I just need to I need to get into it. So Manhattan distance of position is write down what I can. Oh yeah, for sure. Whenever but before I leave, I'm gonna write down some pseudocode for all of this. Um, right, Manhattan distance of the drone. Return absolute value of um. How do you do you calculate it? Oh my gosh, my plans are now. Okay, crap. Hold up. Absolute value. I need to write this. I need to get this down first. Absolute value. Um, get cos x minus right. Cos x minus cos 0 plus the same thing but with y and 1. This is Manhattan distance, isn't it? Oops. Yes, I believe that's correct. Manhattan distance. So, okay, you're right. I need to write this down. Um, crap. Backtrack from treasure while tracking Manhattan. I don't know how to spell Manhattan. The distance, tracking Manhattan distance at each point reached by um, at each point reached by the um, list of coordinates and wall locations. Right? Keep right, append to path to find I don't know if this is going to make sense to you, but I'm hoping that I'll read this back tomorrow or whenever I do this and I'll be like, "Oh, okay, right, let me do that." Append to path to pin to path and execute once it is built. No movement until path is built. We have all info in arrays. Okay. Okay, Jeff. Thanks for sticking with me and making me believe in myself. I met Jeff. He's cool. I don't know. But they encouraged me to use my own brain instead of learning some outside source because is this is a specific situation and the other stuff unless I'm going like specifically for the farmer was here or the farmer was replaced stuff that it wouldn't be as efficient. It's just figuring it out on myself and I figured it out on myself. But I didn't finish. So I'm just writing down some notes for myself for when I come back so that I don't forget. Uh, Okay. Yeah. Um I don't know if I'll be able to update you on if I figure it out, but you're welcome to come back here and I will show you at any point. I should have this finished tomorrow because I feel like I'm really close. But thank you, Jeff. And let me see if any of my friends are live to raid. Yes. I'm going to raid Baconator. Okay, bye, Jeff. They're not playing The Farmer Was Here. They're playing Minecraft, but he's cool if you want to watch. See ya. Oh, wow. Jumped up to 4 viewers, right? Right as I started my raid.